Hey everyone, welcome to yet another episode of Machine Learning Working Group meeting. And today is the 24th of May. We have a few items on agenda today. Let's see. The first one is FFDL, and the agenda says Animesh is supposed to talk about it. Are you on the call, Animesh? So FFDL seems to stand for Fabric for Deep Learning. That's from IBM. Okay. Is Animesh on the call? I'm gonna assume he's probably running late. So let's move to the second topic. Okay, so Nick, you got the second topic in the agenda, which is machine learning manifesto.
Yep, I'm just I'm moving because there's some noise in the other room. Give me 1 minute, then I'll be ready 2%. Yeah, I should be ready now. I can share my screen whenever you guys are ready.
Just to make sure, Nick, you are the one who added the machine learning manifesto, right? Because it says similar to a 12-factor app. And
I don't think that's the same Nick. It's the Nick from University of Michigan or something who wanted to present his own user paying list.
Oh, okay.
But I don't think he's also on the call.
Yeah, whatever works, Wish. We can start with the charter presentation if IBM is not on the call.
Yeah, it looks like IBM Animesh is not on the call, and Nick is also not on the call. The other Nick. Josh has put a point saying contributor experience. So Josh, like, you want to introduce yourself?
Sure. Howdy. My name's Josh Burkus. In addition to being personally interested in machine learning, which is the other main reason why I dialed in today, I'm also on SIG Contributor Experience. If you weren't familiar, SIG Contributor Experience's mission is to make it as easy and pleasant as possible to contribute to Kubernetes, as well as taking care of quite a number of bookkeeping things that we do for the project. As such, we've been trying to attend all of the SIG and working group meetings this season in order to just let people know where we are and what we can do for you. Let me go through some of the doc here. One thing is we are kind of continuously trying to tweak how we handle repo and workflow management for the repos in the Kubernetes namespace. And including changes to labeling, changes to prowbot commands, changes to issue triage guidelines, and many other things. So in that respect, I actually have a statement and a question. The statement is that a lot of those things, there's going to continue to be changes over the next 3 or 4 months. You'll hear from us in test infra on that. We post that to Contribex, SIG leads, and Kubernetes dev mailing lists ahead of time so that people can voice objections before we actually push changes. But it does mean that if you're concerned with those sorts of workflow changes, that you need to be following at least one of those mailing lists. And the question is, do people in SIG, in the machine learning working group, have particular concerns or feedback about things like the PR and issue and docs workflow, the way that it stands within Kubernetes? That are things that we should hear about and take into account.
Sounds good.
Okay, I think there's a no. If something occurs to you later, we've got, contributor experience mailing list, contributor experience Slack account. You know, suggestions are open at any time. Does the machine learning working group have any kind of mentoring program, or have you participated in any of the mentoring activity?
I think, Josh, like in case you're not aware, like this working group was formed pretty recently.
Yeah.
And so we're still like trying to figure out what is the exact charter and like how we're going to actually engage with the rest of the community.
Okay.
I feel like maybe we'll have better answers to a lot of your questions and suggestions like 2 months from now.
Okay. I would say it's never too late to start in mentoring, particularly when you're new and everybody's new.
What is mentoring? So, okay, for like SIG apps, we can mentor people to how to contribute to the workloads API, how to contribute to Helm, right?
Yeah.
What does mentoring look like for a working group since it doesn't own code?
It's a good question. Does the ML working group does the ML working group really not own any code?
No working group owns any code by definition.
Yeah, by definition. However, the material reality is sometimes different.
Okay, that's true, I guess. I mean, like there are definitely many projects that we have here.
Yeah.
And there are things that we're interested in collaborating on as a community, but they don't live inside of Kubernetes core, and they don't live inside of a Kubernetes SIGs repo. So,
Yeah.
yes, well, but it's unclear that that's necessarily the direction that anyone's even going anymore.
Yeah,
CNC,
and that's not
like
having stuff an external repo, and having stuff as an external repo is not a limitation as far as we're concerned. I mean, at this early stage, what I would think would be appropriate is showing up for example, a meet our contributors.
Okay.
Or depending on people's available free time. We do get funding for programs like Outreachy and Google Summer of Code and other internship type programs. So if you have, and I'll tell you from an applicant standpoint, if we say, hey, we have funding for this machine learning related internship position, we will get a lot of applications. So if you have anybody who has the time to do that kind of mentoring, and that's a lot more time, you're talking about minimum of 5 hours a week, probably more, then, as that rolls around for whatever the next season are for those various programs, we'd certainly be interested in having the ML working group participate in those because it is a very attractive thing for, students and unconventional background folks and other folks interested in internships to participate in.
Yeah, so that's a great point, Josh. Like, thanks for bringing that up. Like I said, I think in like a month or two from now, we would probably have a much clearer roadmap and probably have a little bit of consensus within the community too, at which point we can extend it beyond the core contributors to actually start contributing. I feel like right now things are a little bit vague. They're not ready to expand and diversify yet. But these are all great points. And if you can like post these suggestions in the meeting notes doc, that'll also be very helpful because we can come back to it later when you're ready.
And then the last thing is actually pretty small, which is it would be good to have a sort of statement of purpose and link to your working group doc on your Slack channel.
That should be there already.
I don't think
in the Slack
channel. Yeah, I didn't know that was even a thing.
Oh, Slack channel. Yeah, I think I can do it.
Yep.
No, we can get with Sarah.
Okay.
Let me check.
Okay.
You used to be able to do that. I don't know if I can.
Yes.
Okay.
Okay. Yeah, that's a good point. I'll take it as a true item.
Yep. Okay. I will link to more information in the notes. Mostly this was to say, hi, you were here. This is what we do for the project. if you have problems in these areas or questions or things you want to do, ping somebody in contributor experience.
Yeah, that was really helpful. I think a few weeks back we were discussing about repos and how do we contribute. So this is time.
Yeah, and those questions can also go to us.
Okay.
I mean, sometimes depending on what the question is, we have to escalate it to the steering committee. But you should start with us.
Okay. Does anyone have any questions for Josh? Okay. I'm gonna assume the silence means we can move on to the next topic. Just checking again, is Animesh on the call now? Or is Nick on the call? Okay. Sorry, did someone say something?
I don't think so. The other Nick is on the call.
Yeah. The other Nick can now take over the floor.
Okay. Let me know when you see a beautiful white slide.
Yes, I can see it.
Okay. So let's see. This is kind of inspired, sourced by a conversation between like Vish, Kenneth, Scott, and I, and the email thread we started last week around what kind of concrete things would a working group like this actually go and target if the resource management working group would be any kind of inspiration. It was a bunch of people with common interests where work needed to get done across different SIGs. So that was kind of inspiring one of the first working groups, and we thought that the machine learning working group would be somewhat the same. So just to kind of snag out of Vish's email, this is a pretty good summary, I think. Like our goal is to identify gaps and extend Kubernetes as appropriate for supporting all machine learning workloads, right? So if there's any confusion between, for example, what different IaaSes, mentioning just Kubeflow as being one of them, and what we would take on here is a lot of IaaSes needs to provide a end-to-end experience where the machine learning working group would, on a per case basis, look at opportunities for doing some of the heavy lifting. At least as far as I've seen it from the outside, Kubernetes has been really good to target the kind of 80-20% like use cases where, you know, as long as a use case is, or a pattern is common, then that would be a good way of doing it with Kubernetes itself. So where a lot of IaaSes comes from top down to make sure that everything is great and kind of, to some extent, doing, I won't say stopgap solutions, but would need to figure out a way to make it a good experience. The machine learning working group would be a bottom up to figure out how can we enhance existing abstractions? Is there a space for new ones? How do we latch ourselves to ongoing efforts that can, you know, help ease the machine learning use cases and those pain points? Is that controversial in any way? If not, I'm just going to continue.
Yeah, I like it.
So at least from to start with, this was informed by just like our thoughts on, you know, the pain points we've seen and the kind of first class solution that we'd like to see, and the list that Vish he commented on the email thread. In the previous meetings or meeting, I was going over different solutions for boilerplate templating and like from source to deployment. Within scheduling, that's a bunch of things we'd like to see being worked on. Our algo team and or our teams are submitting thousands of jobs, and they come from a background with HPC schedulers and are used to pretty predictable job scheduling, very large scale job scheduling, and the best answer they have in Kubernetes is the job abstraction. And there are many ways where there are things to be desired within that one. Then again, when there's a limited amount of accelerators that tends to be used for training, fair sharing tends to be an issue. Sorry about that. Gang scheduling as a theme has already been talked about in SIG scheduling. A lot of the patterns that we see in the job operators for TensorFlow, PyTorch, Caffe could potentially be helped from extensions within Kubernetes. Also related to runtime, and these are incomplete lists, by the way. I think already now we have ideas for 2 or 3 more runtime related topics. But yeah, loading in hundreds to terabyte size data sets easily, having solid support for accelerators, having ways where jobs can write checkpoints without having to be opinionated about which cloud provider is coming up with it. So there is a lot of different topics that are not tied to any one kind of IaaS on top, which is where people have to come up with solutions and they're coming up with different ones. So it basically creates like siloed environments on top, and that is not in the spirit of Kubernetes. So what we can do now, for each one of these, we have a slide, but I don't know if we have enough time to do it. We have about 9 minutes. So either I skip to the very end. The slide deck is formed so it goes through each one. At the very end, we could talk about priorities and dependencies between them, because I think we need to do that kind of work in order to establish a suggested orderings before we can suggest different roadmaps. So Vish, Scott, whoever is on the call, what do you think we should do?
What we should do in terms of like priorities, or
just in terms of what we do now, we can go through each one, but I don't know if 9 minutes is enough to get through all of it. So to be as efficient as we can, if people have a rough idea of what these mean, then we can talk about how much people care about each one. So we use that to feed into like roadmap, or we just go through as far as we make it, and then we can continue next week.
I would say like at this point, we just want to understand if there's something more that we are missing, right? Maybe just to like rephrase what you're saying, like the idea is to figure out what problems can become part of the Kubernetes layer, either like as a core component or as part of a sort of an official blessed extension that can help a lot of workloads in general, right? Like some of these aspects will help even HPC workloads. So in that sense, like we want to do minimal work as much as possible, but at the same time, like enable Kubernetes to become really friendly for machine learning. So I think I'm pretty confident there's probably more in the core layers of Kubernetes, but this seems to be a pretty good list to start with.
Yeah, Nick, can you just do a quick overview of some of them and see how far we can go?
Yeah, we can definitely do that. So if you were on the call around the source to deployment, we spent a full hour talking about this. This is the first half of it, where some of the things we saw was people are copying a lot of pod templates and job templates. Some people end up solving problems for themselves that they don't end up like upstreaming. So we've seen more than one solution to certain problems. Some data scientists go on just still having problems that other people have solved. So what I'm listed here is basically it's hard to keep things in sync. If people need to start a new project, which one of these data scientists templates do you copy? So it's kind of a bit of a low practical problem, but I think it is a fairly common one. This is where we discussed at least like 5 or 6 different ways of doing it. So that is just to mention that part of it. That's maybe is a whether that should be in Kubernetes or not. That's something we can discuss.
May I ask? Hi, this is Dave Ronchek. Have you looked at Kubeflow? There are other folks at Intel working on that, and I was just curious if you had a compare or contrast.
Oh, that's us.
Oh, okay.
So yeah, I talked about templating here because Vish listed it. So it's just to mention it, and yes, we have a project within the space called MLT. We know that scaffold could be used. We know that draft could be used. There's two others, there's Forge.sh and Red Hat's source to container project as well. So we have a like 2 weeks ago, I think 2 weeks ago or 4 weeks ago, we had like a pretty elaborate talk about this problem in particular. Yeah, same thing. I'm really just pulling in things that that we presented back then, where the what data scientists tend to care about is I make a change to my Python file. I need to see it almost in real time in the container. So that has been some of the struggles that we've had. Here on the right, it was based on a user interview, 3 or 4 different ways that he or she would be doing code editing. Either from home, push it to GitHub, pull it down, the developer laptop, be attached to the Samba share and doing editing as the job would volume mount that in. So like a pretty fragile setup, but you go to a long length in order to get the kind of very interactive, real-time kind of developer experience. So for bin packing, that's another issue that we've seen internally, where if people, for different machine learning workloads, there is a very different requirement for the amount of acceleration you need behind it. Some workloads can deal fine with 1. These are just to illustrate some pods requiring 1 or 2 accelerators. But if some voice models need, for example, 4, they can end up waiting for a long time before we see those jobs being scheduled. So the only alternative right now is for that user to go and cordon off machines whenever he or she needs to launch their jobs. Is there anything you want to add here, Vish, in terms of bin packing?
No, I think you summarized, and there are also like additional challenges that I think will come up that if we have a cluster of machines which can either be used independently or together as a single cluster. That's something that Kubernetes hasn't thought about. At least in the past, I haven't seen discussions around that.
That's right. Yeah, so like the accelerator interconnectivity as well, right?
Yeah, it gets into literally the topology and like how can we get Kubernetes to schedule against a given topology.
Yeah. And for job queue management, at least what we see, people use the job abstraction just like they would have done with Slurm or Moab. But compared to those tools, there's very little, a few mechanisms for doing introspection and for doing accounting on those. When people start something, they don't have a good idea of when it's going to start. They don't have a good idea of who is using what. They don't know where things are running. So yeah, like at least internally, we have like thousands of jobs like lined up, and there are some pretty bare bones things that people are asking for. So those are some opportunities for going and help enhance job controller, or to go and kind of explore, if we want like a job version 2 or something like that. But it's just to explain, like the problem is really this, fine. People schedule many jobs. People try to use priority, but it's only at admission. So in all, there's a lot of things in terms of the experience like that could be enhanced. When it comes to sharing, we have a quota mechanism, but it's not nearly as sophisticated as the ones that you'll see in traditional HPC schedulers, where you can have like a cascading quotas that can apply over time, that fits into preemption. that is based on some kind of budgetary measure of who is funding the cluster. So some of those concerns, we've been looking for answers as well, trying to write controllers on top of quota. But in general, kind of pushing some of these down so they become almost like a de facto standard would be amazing. For some of the gang scheduling, there are already, as I said before, some initiatives in SIG scheduling. Scott could probably comment on this. Or what a lot of the things we see today is data parallelism, but with upcoming specialized hardware, you might be able to see a lot of model parallelism as well. So this this issue is only going to be exacerbated by it. We've seen a lot of kind of specialized job operators come up. There's one for TensorFlow. Then they've been forked for early versions of MXNet. We forked it for PyTorch that was contributed to Kubeflow, but a lot of them follow the same pattern. So there might be an opportunity to find a way to enhance either the job abstraction or some abstraction within Kubernetes that does a lot of the heavy lifting. So we make sure that whatever we come up with is scalable and robust, and maybe more importantly, has the same experience across different frameworks. So people don't have to learn a new CRD to do something special for TensorFlow versus PyTorch if there's no good reason for it. Does that make any sense? Please speak up if there's anything where I'm making like gross assumptions. I'm going through this pretty quickly.
One observation is that, you brought up these alternate schedulers, Slurm and Moab from HPC, but there are others specifically in data analytics like Spark and Storm that I think are commonly used in maybe not so much the training aspect of machine learning, but executing it later. Those are the ones I've encountered more frequently at conferences involving data analytics with machine learning and AI.
Yeah, but Spark, so okay, Storm is really about stream processing more than anything else. Like, it's a true stream processing. It added micro batching after the fact, but it's really meant for processing streams of data and kind of giving your materialized views or like acting on it immediately. Spark and MLlib are good for certain types of machine learning, but for deep learning and training, it's probably not the way you want to go.
Right. Yeah. They're more like applying it after you trained your neural net and getting it to run and give you results. And there are lots of people interested in running those workloads on Kubernetes. I don't know if you consider it out of scope of this working group or not, but there's interest in the topic.
We already have a lot of work that's gone into running Spark on Kubernetes. So we've like the workloads team at Google and SIG Big Data did a lot of work to make Spark Kubernetes a first-class scheduler in the same way that Yarn, Mesos, and Spark Native are inside of Spark. And we also have the Spark operator to kind of give Spark jobs first-class support in the Kubernetes API. So there's a lot of work there already, but that's, again, still not the right way for...
I'm just asking if you are declaring that that's out of scope for this working group, that it lives somewhere else, or are you contending there's no need for it? I'm just wondering because I'm interested in it, but maybe I came to the wrong place. That's my...
I think, we are heavily biased by deep neural networks, but this is an ML, forum. So I think it has a lot of value, and I don't think they're going to be mutually exclusive. So, your input would be... I'm sorry?
It definitely would be welcome, but Spark does kind of have a home inside of SIG Big Data.
That's right.
So, and that's where most of the Spark contributors who overlap with Kubernetes contributors live for those discussions. So like, I'm not saying we shouldn't talk about it, but ultimately if we want to look at Spark and MLlib as part of what we want to tackle, then we should probably involve them.
Okay, gotcha.
Yeah,
All right.
one of the main steps for ML would be like data pre-processing, and like Spark could, in theory, be a really good solution for that phase. So in that sense, like data pre-processing is probably the more I don't know, time-consuming task than just training. So in that sense, we would love your feedback here.
Okay.
Well, it's just that I don't. So getting things upstreamed into Spark is extraordinarily difficult, right? In terms of like major changes. So it took over a year to get the work that was done in a fork to integrate Kubernetes, maybe a year and a half, back into Spark. So we could, in terms of like understanding use cases and so forth, we could do that. But if we really want to change the way Spark works, or like try to modify Spark to better suit ML or stream processing, I don't know if that's something we want to bite off. And if it is, I think SIG Big Data is a better place to bite that off than here.
That's fair. I think what I was trying to say was not extending Spark, but more like
How do you use it?
Yeah, how do you apply it here?
I guess.
And it might just be like guidance on how to apply it. It's not necessarily build something new.
Sure.
Okay, well, I think you answered my question. Thanks.
All right. So this is one area where we already did one open source project, like the Kubernetes volume controller. But this is a general problem. And even with the Kubernetes volume controller, that there are some things that we'd like to enhance or to improve in terms of the experience. But for example, for the unit demo that we have for our tool, the brain scans data set is about 1 terabyte. So it is a non-starter to start copying things around. So how do we make that a better experience? Because it's going to be something that even for, it's like a straight out Kubernetes job is something that you'd like to have wired up in some way. So yeah, I don't think I have more for this one, unless Scott, you have anything else you want to mention?
No, I think that's pretty good. I guess the one thing to sort of keep in mind is the demands on having data local and close by, right? So because you're visiting the same data over and over as a model's training, the closer you can get it to the device and keep it there, the better.
Right. Yeah, so I think from a long history of working for kind of pluggable device support, we bought ourselves a lot when it comes to turning these things on in Kubernetes. So we do have the device plugin API, but this is more like a call out to its continued investment and to its hardening it, getting things like pluggable accelerator metrics in. So it's not so single accelerator specific. Anything else to add here?
I think there's probably a good enough community around device plugins and like resource extensibility at this point that we don't necessarily have to tackle it here. But I feel like where we can add value is like provide feedback from a user standpoint as to what matters and what doesn't matter. Because oftentimes some of the device plugin work is like vendor driven, where a vendor develops a new hardware and they want to expose all its functionality, while when we approach it from a user standpoint, a lot of that doesn't really make sense and it doesn't like gel together, and the overall user experience isn't what we were originally thinking of. So I'm hoping we can bring in that user voice and bring in that ML expertise and then say whether this makes sense or not, at least from an ML standpoint.
Right.
Now, let me ask you this. When you want this support, is this going to be typically a scenario when you're standing up your own Kubernetes on your own on-prem hardware? Because if I'm hosted in GCE, for example, and they have the TensorFlow processing units, aren't those consumed more as a service so that you don't have to have Kubernetes manage those things yourself?
So, Vish, I guess you can talk for the Google use case.
Okay. Yeah, that's correct. For like Google has chosen to expose tensor processing units as services or endpoints, but Google also exposes GPUs, and they are not exposed as endpoints; they're exposed as devices. And you are correct in that, like, if you're spinning up your own Kubernetes cluster, you would have to deal with these things. It's just that, like, you can't like now take K8's core and like whatever you get as part of the code release and say now all these workloads are running. You'll have to install a few extensions at different parts of the system in order to get the whole thing working for ML.
Okay, thanks.
Yeah, so that's that. And then, pretty like practical things like if accelerators break, it could be hard to tell, but like Vish said, resource management working group is probably the right place to do this. But we can bring in if things that we are seeing in amongst our users. So this thing we mentioned before, and I've heard about this concept of persistent jobs for the first time from Ken. But yeah, like almost all jobs will output checkpoints that you will want to keep around for as long as you can, because you use them for experiment comparison, which is almost the most important way of using that output. Because as you know, standing alone is really hard to understand those metrics, but they tend to be relative. Here on the right is another output from our unit model, where we would be outputting to Google Storage, and then we would point a local TensorBoard instance to it. However, it would be nice if there would be another level of indirection where, from the jobs perspective, you don't have to worry about which backing store that is actually being used. Ken, do you have anything else to add to the persistent job?
Not really. I mean, basically, for distributed training, it's something like all the jobs for Kubeflow training, TF training, PyTorch. They all use a similar pattern we've said before, and then there's also stream processing, which kind of uses similar patterns sometimes too. So it's just something that people continue to ask for, but that we decided we're probably not going to do in core. So it's something we'd like to do as an extension and as a common extension that can be leveraged across the board.
Yeah, that'll be super useful. Vish, you could probably talk to this one.
Yeah, this is more on like the enterprise or like the vendor side, where eventually once ML starts taking over, then there will be more and more utilization demands and also like isolation demands, and this is pretty difficult to achieve given the current state where like VMs are sort of the boundary for most of the hardware devices, and so I guess one of the themes would be how do we work with the existing multi-tenancy efforts, and like what sort of primitives do we have to enable at the node or at the cluster level in order to make like the Kubernetes machine learning clusters multi-tenant ready, while at the same time not sacrificing performance.
Right. And there's like a myriad of different ways of wiring things together, because it's layering, right? Where we have the Kata container initiative with high speed one container VM wiring. I think there's like 3 or 4 other ways of running VMs in Kubernetes, either just for hosting legacy applications or for actually wrap the individual workloads in a VM.
Yeah, I think the place where, I don't know, maybe this is my bias, and I think that's where I would love feedback from this community, which is my assumption is deep learning really cares about performance. So even like 5% performance drops are actually problematic. And so whenever we add a VM layer in, there's going to be non-trivial amount of performance hit. And so I haven't, like, I don't know what's the right model for this space. I think for the pure services space, the performance set is most likely okay for many apps, where the added security is much more important. But I'm not sure how much that matters here in this space.
Yeah, so those are other things we can go maybe sieve out from it's part of the kind of user pain points gathering process as well. But maybe like at the end, when it comes to a roadmap, we can see which things are ongoing efforts and what requires more research.
Yeah, all I can suggest, I don't want to turn this into a promo, but just full disclosure, I do work for a vendor, VMware. But hypothetically, if there was, I'm not announcing any products, but hypothetically, if there was to be virtualized GPUs or accelerators, I assume that might be something that you'd be interested in.
What is a virtual?
Is it like multi-tenant GPUs maybe? But yeah, like, I guess the most common thing we've seen has been bare metal on-prem virtualized cloud setups. But it would be interesting to either do studies of what people do or what people would like to do. Right? If someone is trying to string together a multi-tenant appliance, how would people go about doing this? So maybe it's a bit more of a hypothetical, but I'm sure that Vish, it's related to your work with GKE.
Okay.
Sorry, Nick. I think Vishakan was given a reason why distributed training will not be supported in Kubernetes core, but I didn't get that.
Can you say that one more time?
I think either Vish or Ken was given an explanation why distributed training was a request that an extension to Kubernetes can be added, but they were not going to offer native support in core.
Yeah, like that user request also comes from us, where you don't want to have a different experience based on different frameworks that basically follows the same pattern when it comes to scheduling things and keeping things up, or sharing certain pieces of information across these jobs so they can get in touch with one another.
So for job, it's already V1 is primarily the answer. We could do a V2, but I mean, if we actually want to move something fast through without, so right now, in order to do any API change, you have to get agreement from the architecture committee. And they're being really, really conservative with what they're letting into core. If you want to do it as an extension, that's fine. I don't think you're going to get concurrence from the architecture committee to add a stateful job as a core resource, unless you first do it as an extension, and the extension becomes so prevalent and so common in use that adopting it as a core resource is, basically just the best thing to do.
Yeah, I mean, to add to what Ken was saying, the general guidance is not that the community has to stop working on these kind of things, but it's just that not have the community think about everything as core, in the sense that we now have the tools and the extension points that we need to prove new APIs and make sure that it's solid and robust enough to be supported for many years to come. And so from that point of view, I don't think Ken was saying, no, we should not do it. But rather what you're saying is like, let's not go change the core constructs or add core APIs, but rather let's build it as an extension and then make sure that it works really well before we bring up that conversation. I feel like the secondary conversation of core is probably not that important, because we all want Kubernetes to succeed for ML users. And if we happen to ask them to install one add-on or one or two add-ons, that's probably not the end of the world.
The general thing is this: if you're going to do something as a core resource now, and there are some things that are, it's not saying they're never going to take any new core resources, but you really have to bring a very strong argument that we have to do it as a core resource, and here's why. And for stateful job, it's kind of already been proven that batch workloads can be done as an extension. So we don't really have a strong argument to do it in core first and evolve it via that path. if we do it as an extension, and again, it becomes so prevalent that, everyone's already using it anyway, and we see it tons and tons of different uses, and it's very mature, there's nothing to stop it from evolving from a custom resource definition into a core resource.
I see. Thank you.
Right. So I think it's we can find out the details of this, but it's maybe just a shout out from us being. I think we saw this pattern with Mesos, where a new framework is easy to make, but making a good and stable and scalable one is really, really tough. So if there's going to be a lot of operators that are of varying quality, that users are better off having a common abstraction, and that again is a bet and a hypothesis, but maybe worthwhile pursuing. Did that make sense? Like, we only have 2 more. Then let's see, we're way over.
Yes, it makes sense. We can go over the rest.
Alrighty. So, Vish, do you want to talk to this in terms of how this would be helped from bottom up?
I mean, the way I was thinking about it is not necessarily a separate API. Like, if you just keep a history of jobs, that by itself is like an indicator of the previous experiments we have run, right? So, like right now, jobs has a whole bunch of issues. But as Ken said, it's V1, so we can't really change it. So the only alternative we got is like we have to write extensions to work around the limitations of jobs. And so I was just calling out that this is a common problem where like people want to track their experiments, and whether it's for ML or for HPC or for like just pure batch, like it's a very common use case. And whether we do it as part of the stateful job abstraction or whether we do it as a separate extension so that it works for other controllers, like that's up to us. But I think giving people a way to do this and giving people a path to start thinking in terms of like more and more Kubernetes native abstractions is probably a powerful and important thing we have to do.
Right.
Like the fact that once you delete once your pod dies, the job doesn't know what happened previously, or pod gets deleted, job goes berserk. Like that's not going to work at scale.
Yeah, but the one thing I'll point out here is that if you take Spark, for instance, they provide their own history server, right? So like at an application level, and like you can even think of TensorBoard in a certain extent as a way of storing the results or history of jobs that have been run iteratively, right? So I don't know, like, what does the core thing look like?
It's the like I think Nick had a slide about that previously, right? Which is like job output tracking. Like you had so you want to audit what inputs you gave, and have some unique identification for those set of input parameters.
Yeah.
And then you have set of outputs, and being able to go from inputs to outputs through an ID, that's something that's not easily possible today with jobs. And I would expect that to be something important even for other custom controllers too. In that sense, like,
but it's the inputs and outputs and the way those are handled are something that's kind of application specific. And I don't know, my only thing about this is I don't see what we need to do in core to do this. Like you write it to a database, right? Like
like I said, I'm not saying we should change the core. I'm just saying that it's a common pattern.
Yeah.
That it's worth abstracting, right? And I'm not saying it's worth abstracting in core. I'm just saying that it's a common enough problem that.
So Ken, I think we saw something similar, like in the Kubeflow community where they were talking about history servers as well, and it just seemed to be a wider issue. Right? If you want to have a way to keep track of objects in their history forever, if there is a way to plug that in, and maybe it's probably something you have on the side that does backups of it and then stores it in some kind of approach.
This is David again. That's my hope as well, that we are able to, but I don't want to stop people from experimenting or thinking like outside the box. For example, and this may be an absolutely crazy idea, so you should dismiss it immediately, but like, what if we overloaded using labels or something like that to help with experiment tracking? Like, I think there might be some things where we could use Kubernetes core constructs to make experiment tracking at a higher level easier. And I'm all for that. I don't want to like stop creating potential solutions just because we have Katib already running on Kubeflow.
Here are my primary concerns with this. It's not clear to me that the results of an experiment are closely tied to the life cycle of a Kubernetes cluster. In fact, I imagine that you might turn clusters up and turn them back down as over the lifetime of multiple experiments. That you'd want to be able to store the results of an experiment and the inputs outside of the scope of a Kubernetes cluster.
Similar to logging.
Yeah, sorry. You're exactly right, Ken. I didn't mean to suggest that we wouldn't need something like that.
That's my only concern, really. And then the other thing being that you may have multiple clusters turned up simultaneously with experiments that are being run, and they may want to be able to share the results and the collection of experimental data as a global resource. So I don't think it's as simple as saying we can build an abstraction inside of a Kubernetes cluster that, I don't know what it looks like. I think it's a harder problem than just saying we can just build some abstraction that handles that particular.
Well, I think we're not looking for, well, we have some idea of some solutions for this, but it's mostly being aware of there being a problem. And I think it's a good indication that if it's a tough problem, then, we tend to walk around them for a bit. So yeah, I think it's just acknowledging that whoever builds an IaaS today will have to deal with some of this. And it's yet one of these kind of easy to get into a silo if there isn't like a good way of meeting at some kind of common or shared format somehow. This is something we can leave until we have an idea about how to go do it.
Yeah, I mean, like having something really simple like Heapster, for example, which is dumping historical application, like historical states of objects from the API server for certain controllers, that we can think of like really simple solutions and not overcomplicated to start with. I think at the end of the day, people just want to run something, and if their cluster goes berserk or like Jobs API goes berserk, there's still some way to go look at what happened previously.
Yeah, but I mean, it's not clear to me that that's something. I would be interested in seeing something more like a generic job history service that you could stand up and run, and that you don't really care about whether the underlying implementation is based on Kubernetes, run as a service, and something that's backed by multiple types of durable storage. So you could put it on GCS, S3, HDFS on-prem. Yeah. That type of a solution is more. And I don't know if Kubernetes could be part of the answer there, but I don't really know how much of the answer it is.
Yeah, that's fair. Yeah, but anyways, Nick, you just got 3 minutes.
All right, yeah. Model serving, that's also yours, so you get to talk to it.
This is actually Ken's thing. Ken, serving.
Yeah, so, there's some challenges, particularly with TensorFlow serving. Particularly if you want to try to get it to work on GPUs, and how we deal with it as an abstraction. Also with running experiments, it's not necessarily the same use case that you'd have for typical deployments, like stage canary type deployments that you do with serving workloads on Kubernetes. Auto scaling becomes a bit of a problem, in particular with GPU. It's not clear. So with a CPU bound workload and with TF serving as a CPU bound workload, you can pretty much auto scale off of CPU utilization as a good trigger. GPU duty cycle is probably not a good trigger. Request latency might be a better trigger, or total QPS, which is probably tied directly with request latency and batching. There's just a lot of things that we could probably do better and potentially in a more general way. And then ultimately a question becomes, so TF serving is, it works for TensorFlow out of the door, right? But there's nothing that stops you from providing other plugins for TF serving to serve other different types of models. Like, I think there's an XGBoost thing in the community, right? And there's a Kathy2 one.
Yeah.
So, is that the right extension point? Is that the right way to serve models on Kubernetes in general? Is the right thing to do to invest effort in TF serving to support other types of models, or is it to provide another level of abstraction above TF serving? These type of questions.
Sounds good. So I think the last one here is, we don't have time for this, but we tried to start a, you know, a list here, which is like for each one of the slides, we can go and vote and comment and do whatever and figure out which SIG is relevant for it. And if there is ongoing proposals, we can write that too. So maybe in 2 weeks' time, we will be in a better position to figure out what is less ambiguous and what can we go and do now versus what requires a lot of effort but is worthwhile for us to look at. Does that make any sense?
Yeah, that makes a lot of sense. I think it might also be worth posting your slide deck and also this list of priorities with other sponsoring SIGs, just so that we make sure that we have that we give a heads up for all of them and hear any potential concerns or maybe like get more support too.
Right, and also adding to it, right? So if there were, for example, per camps request ideas about how to enable profiling or whatever we have missed here, we can go add and we can figure out who's interested in what, because it will only become real if people start working towards those goals, right?
Yep, that's true.
Yeah, thanks, Nick. Can you make a copy of the slides and recording available to us?
Yeah, so they are, I linked to them right now. The charter, Machine Learning Working Group charter right here, and let's call it the priorities. And then now there's a spreadsheet to that. So is that good enough here? Or do you want it to have it moved up further?
It looks good. What of the recordings from
Yeah,
today's
the
presentation?
recordings. Should be on. It should be on YouTube.
Perfect. Thank you.
Sounds good. I don't have anything else. Hope to see people kind of chime in with what they care about, and then we could figure out like which topic to attack first, so we can get a bit more focused. Even today we were all over the place, but that was on purpose. So like we're gonna start funneling and get focused.
Yeah, that makes total sense.
Alrighty.
Thank you, Nick. I'm going to end the recording now.
Thanks a lot, guys.